Hi, Kay. Hi, everyone. If you don't know me, I'm Nisha, and I will be leading today's AI-powered image classification workshop. So let's go over the agenda. Oh, did everyone get the QR code? Yes. Grab that. Okay, perfect. Yeah, so what we're going to do is just start by defining what image classification is, and then looking at some real-world applications for it across different industries. And then we'll cover like the basics of neural networks and convolutional networks, followed by this one of the convolutional neural networks and a data set that we're going to use. Then we're going to learn what transfer learning is, and we're going to apply that in a Google Colab session. And just to be like clear, I am by no means like any expert in all of this. So I will take you through like what I know, and we'll just kind of speak more at a high level, at least for the most part. But if you have any questions, like feel free to ask, and I'll do my best to answer. A lot of this knowledge that right now comes from my like internship and then just like some classes and things. So yeah. Are there any just questions or anything before we get started? Okay. Okay. So the first thing I kind of wanted to ask everyone is, where have you seen AI classify images in real life, maybe? And just to give like a little definition of what AI image classification is, it's basically assigning a label to an image from a predefined set of categories. And so does anyone have any real life like examples that they think they've seen AI image classification? Or any industries that they think it's being used in a lot? Yes, Jason?
Ooh, the Amazon grocery stores that got shut down.
Yes. Yes.
Like manufacturing for vehicles and things.
Yes. Manufacturing uses classification a lot.
On your phone, like in the Photos app, it also sort faces, like which photo would face.
Yep, that's image classification as well. Okay, awesome. Those are some really good examples. So just to go kind of more into it, these are some other industries that utilize image classification. So healthcare uses it to scan like CT scans nowadays, like patient lab reports and things like that, to help even with defining like helping nursing situations. And then also in retail, it enhances like shopping experiences by recognizing products and personalized recommendations for people. Security systems do facial recognition, authentication, like surveillance. In agriculture, you might not have thought of that one, but they use it a lot for like crop disease detection, yield predictions, and other things as well. And then also autonomous vehicles use it for like their cameras, object detection, and seeing like pedestrians and things like that. Yeah. Is there anything that any questions on this part? Any comments? Okay, cool. Yes, let's move on. So this impact is growing daily, and so we are going to kind of learn about how to understand this a little better. So to understand this a little better, we need to know how neural networks work. So I think like 2 weeks ago, we kind of did a workshop on neural networks, but just to kind of go over that again, they basically mimic how the human brain works and processes information. So each neuron takes an input and applies like a mathematical function. And if you were there, we kind of learned about that. And then it passes that result to the next layer. And instead of recognizing objects immediately like humans, the AI interprets images as like a grid of numbers. And so where each pixel has a value of red, green, or blue. And a useful analogy for that is like, when you see a blurry image for the first time, at first you might only recognize like the outlines, and then maybe the textures, and then finally after that, you'll see the full object. And so that's kind of how the neural network also processes images. And it like gradually refines its understanding through these layers. So each layer in the neural network extracts these complex features one by one. The input layer receives the raw pixel data, and then there's hidden layers which detect like the edges and textures and shapes that I was talking about. And then the output layer finally like classifies that into an image category. And so these traditional networks are good for language processing, but they struggle with images because they don't like, there's certain things in the layers that it doesn't do, but we won't get into that. And so this is where convolutional neural networks come into play, which we'll discuss next. So just something to think about, like if you see a blurry image for the first time, how do you figure out what it is? That's kind of what a neural network does, which I explained earlier. Are there any questions on that part? Okay, so as I said, the neural networks work well for the structured data and the language, but they struggle with images. So that's why convolutional neural networks were developed. And these are optimized for images, basically. And so instead of looking at an image as a whole, the convolutional neural network, I'm gonna say CNN now, uses convolutional layers to detect like the small features like edges and textures that the neural network couldn't really make out. And so they use like different layers like pooling layers to simplify the image. And then finally the last layer connects it all together. But we're not going to go super deep into that, but it's there for your information. So I just wanted to ask, maybe we can have some discussion on this. Like, does anyone have any answers for why they think AI might struggle with recognizing certain images that humans can identify easily, or and like why might that be? According to like maybe the CNNs. Does anyone have any thoughts on that? Yeah.
Probably like classification from images that have sort of like similar like pixels or like RGB values. Sometimes I think they get confusing.
Yes.
But you get most of their results.
Yes.
Like for example, zebra and olives or something, like sometimes they'll classify it wrong.
Yes, exactly. That's so true. And that has a lot to do with basically like the lighting of the picture, or like if the image is rotated or not, or if there's other like objects in front of the image and it doesn't understand like the depth and perception of things like that. And so that's something that's like constantly being worked on. And this is where convolutional neural networks come into play as well. Yeah. Okay. Okay. So what we're going to be doing is talking about this model called MobileNet V2 and this data set. But before we get into that, I kind of want to talk about what this model is, and then I'll give a little context to what models are if you're just like really new to everything. So basically, many people think that large models will be better because they can learn more, they can do complex patterns, and they're trained on a larger data set, so they achieve higher accuracy. But I want you to think about maybe why a small, before we dive into it, if we can infer why a small model might be better than a larger one. Does anyone have any ideas on that? Yes, yeah.
A large model is really expensive because it's a lot of math and it's slow, and you might wanna use the model on your phone or something, it's just hard to do.
Exactly. Yes, you hit all the points there. So he mentioned it's like costly, so there's a lot of computation costs. It might require a lot of data set training, and then you might want to use it on your phone, which is not going to be possible if it's a really big model and requires like, I don't know, a GPU or something. Yeah, exactly. So Now we're gonna talk about MobileNet V2, which is a small model. And it was developed by Google and designed to be lightweight, which means that it can run on your mobile device. It uses depth-wise separable convolutions, which is part of CNNs. And it reduces its computation time with that, but still like is able to maintain the accuracy even though it's so small. And it's already been trained on millions of images from ImageNet, which is a data set online. And so we are going to leverage its knowledge by using transfer learning, which we'll talk about in a second. So we are going to we're going to fine tune it, which is transfer learning, on a data set called CFAR10, which is a really common data set of 60,000 small images divided into 10 different classes. The classes are like automobiles, birds, cats, deer, dog, frogs, horse, ships, and trucks. Yes.
I had a quick question. I don't know if you know the answer to this, but I was just curious.
Yeah.
How would you make CNN like lightweight? Like, is there like, what is the key difference between, like, I know like lightweight ones you could like use on your mobile devices and everything,
Yeah.
but like, what makes it like that?
Yeah. So basically it comes down to like the numbers of, I don't know too much, but what I do know is definitely the number of parameters and its training data set that it's on. So it's kind of like for a large model, it's gonna have a lot of parameters and a big token size. So it need more training data set and like require more computation. But for a smaller one, it doesn't need as much, which means it might not perform as well in certain scenarios as well. So there's like that trade-off for both situations.
Okay, thank you.
Yes. And there's also a difference in the convolutional layers itself called depth-wise separable convolution layers. But I don't know much about that.
Okay.
But yeah, I don't know if anyone else has answers to that as well. Yeah, good question.
Thank you.
Yes. Okay. So now we're going to talk about what transfer learning is. So transfer learning is an approach where we use a pre-trained model. So in this case, so we use a pre-trained model and then we fine tune that for a specific task instead of training a whole new model from scratch because we don't have the bandwidth for that. But we do want to leverage what's already been made. And so this is really powerful because it saves time and the computational resources while still being able to achieve good results and on a data set that we want to use for our specific task. So today, we're going to use MobileNet V2, which I talked about earlier. So that's the CNN developed by Google. And so we're going to use that because it's already learned about useful images from ImageNet that it was trained on. And so instead of training a new model from scratch, we're going to use that and then fine tune it with CFAR10, which is the data set I was talking about earlier. And so this is going to really drastically change the training time that we need and improve the accuracy instead of creating a new model. Yeah. So just to recall and retain that information, does anyone want to like say, why do you think reusing an existing AI model is helpful? Basically the transfer learning. Yeah.
Reusing the existing models probably gonna be helpful because, you know, it's like you said, kind of retrain it, like waste resources and computation,
Yes.
as well as if you reuse an existing model, it can be trained on way more data than you probably have the ability or capacity to train.
Exactly. Great answer. Anything else? I think you kind of hit all the points there. So it doesn't require huge data sets. It lets us build models even with limited resources. And yeah, instead of starting from zero, we can use transfer learning to use this pre-trained model and adapt to our task. that's kind of the summary of that. Okay. Awesome. So now what we're gonna do is actually apply this into Google Colab, which I linked on here on my end, but I don't see it on here. Oh, just kidding. Wow, wait, that was really cool. Okay. Awesome. Can I send it in like the Discord or something? No. Oh, you got it? Okay. Or wait, yeah, okay, perfect, from the Canva flag. Yes, okay, so I'll just give you a minute to open that up, and Leo is gonna send it into the Discord, so you guys can all follow along as we do this.
It's in the general.
Yes. Wait,
Just say out loud. So you can-
for those people on Zoom, the Google Colab is in the general tab in Discord. So you can follow along as well. Are there any questions so far before we get into this a little more? Okay, cool. Oh, wait, like another minute? Did everyone pull it up yet? Did anyone not pull it up? Yet? Okay. Awesome. Okay. So just to briefly like preface before this, yeah, as I said earlier, how I made this collab was a lot of stuff from my like internship, and then I kind of just changed it up accordingly, and so that's where this kind of comes from. Cool. So before we start working with the AI model, we need to import a few like key libraries. So TensorFlow is our main deep learning framework. And then Keras is like a Python API, so it makes it easy to build in models. NumPy is going to help us handle the numerical data that we have. And Matplotlib is going to help us show the images that we have. And then we're also importing open like CV for the image processing. And then finally, Google Colab's files module for like uploading our own custom images when we infer at the end. And yeah, as I go along, just feel free to raise your hand and ask me questions or tell me to slow down or okay, it's taking a sec. Okay, connecting. I should have ran that and then spoke. By the way, has anyone like done image classification like this before? Couple people. Okay, cool. So I guess it's pretty new to most people. Yeah, that's awesome. Okay, so if you haven't used Google Colab before, by the way, it's basically just a bunch of text, a bunch of chunks of Python code with, you can put text in between and you can run each of these sections like one by one. So yeah, we just did this first part, which is step one, installing and importing all the libraries and dependencies. Okay, awesome. You know what? I wish I could like zoom out on this or something.
Zoom out a little bit with control minus, but keep it pretty big because it's hard.
It's hard to see otherwise. Okay, you're right. I'll do one just so that you can see a little more on the screen. Is that good?
Yes.
Okay. Oh yeah, the code gets small. Okay. Cool. Okay. So yes. Now the next step is we're going to load our data set. So this is the one that I talked about earlier called CFAR 10. And so this data set contains 60,000 images in those 10 categories that I mentioned. And the data set is already built into TensorFlow, so we can access it easily. We can then, so yeah, I'm going to run this as I speak about this actually this time. Let's do this, and I'll talk about it a little more. So yes, as I said, it's already built into TensorFlow. So we get it from here in keras.datasets.cfar10.load data. And we store it in these values. So we have the training and testing for both X and Y values. And we're going to normalize these pixel values by dividing them by 255. Remember, I said that images read the computer reads the images as pixels, so that's 0 to 255. So we're going to divide them, and then this makes it easier for them. This handles the model like more efficiently, helps it handle more efficiently. And then we're going to display some images that are from this data set. So we can see here, if I scroll a little down, hopefully you guys are following along as well, but it displays an image from each of these classes here. And notice that each of the images are very small, 32 by 32 pixels. That's because the CFAR10 data set was designed for this quick training on like these small data sets like we're trying to do right here. So if that was like questionable for any of you guys, as you can see, it's like very blurry in our eyes right now, but yeah. Any questions on this so far? No? Cool. Is everyone following along? Okay, perfect. Awesome. Okay. This part gets a little technical, okay? So just bear with me and we'll go through it and hopefully we'll all understand. So remember that we said that instead of training the model from scratch, we're going to use MobileNet v2, which is a CNN model developed by Google that has already been trained on millions of images from ImageNet. And so we're going to benefit from the knowledge that this model has already gained and apply it to the CFAR10 data set that we just loaded. So I'm going to go through this code as we do that. And oopsie. Gosh, I hate computers. Okay. Cool. So, okay, there's a lot of comments on here just so that it's like very technical. So I wanted to make sure everything is explained. So basically, this first line, base model, is what's actually loading MobileNet v2. And some of the parameters in there, like the input shape. So this is going to show that the model expects an input size of 32 by 32 pixels that we wanted with the 3 color channels, RGB. And then the include top false, this is going to actually help with this transfer learning part. So it's going to remove the original classification layers of MobileNet, and we're going to add our own layers on top, like we talked about. And the last one is the weights. So this is going to load the pre-trained weights from ImageNet, which was the data set that MobileNet is trained on. So then we can use that knowledge. And then, how does this work? Okay. And then, okay, so now what we're going to do is there's a line that says base model dot trainable equals false. So as we said, MobileNet v2 has already learned useful patterns. So it can see like edges, textures, and shapes. And we don't want to change these early layers. It's like kind of like a kindergartner. Like we wanted to bring it down to a kindergartner level where it still has these general purpose knowledges and feature extractability purposes. But now this means that the new layers we add on top will be trained. And so we're going to turn it to false so that it prevents it from modifying these original layers. Now, this last part is we're going to add new layers on top to be able to adapt to the model of the CFAR10 classification. So just going through each of these lines here, so we're just putting base model in as the first value, which is what is our actual model. Then this function here, global average pooling 2D. So it has to do with the layers, and it's going to reduce the number of parameters, reduce overfitting, which are some keywords and other things that I think it's okay if we don't get into right now. But just so that you have that knowledge, because it's up there, and I don't want to confuse you guys with too much, but at least make sure you know a little bit. The next line after that is the layer that's gonna learn new patterns, and it's 128 because there's 128 neurons. ReLU is a built-in like layer. It's gonna dense layer that it's gonna use. And then finally, this last layer is the final output layer that we talked about, those 3 layers in a convolutional neural network. That's going to actually predict the which class from CFAR10 that the image falls into. And so yeah, it's going to convert that for us. Okay. So hopefully everyone was able to run that part and load all those things on there. Cool. So now that we've built our actual model, we need to tell it how to learn. And we're not going to get too into this, but we're going to use the Atom optimizer, which is going to adjust the learning rate dynamically to help us improve the training. And then we're going to use the loss function we use is called sparse categorical cross entropy. And this is ideal for multi-class classification, which we do have. We have 10 different classes, as you might recall. Okay, then we're going to train the model for a certain amount of epochs. And so right now I put 3. And keeping it shorter for now is going to help make our training faster for this demonstration purposes. But if you increase the amount of epochs, it might be even more accurate. But for now, we're going to do 3 and see how that works. Okay, so we're going to run this. Any questions on this so far? There's like a lot of terms and like a lot of things going on, so it's completely understandable if you're like, what is happening? But hopefully take like the main parts from it and the high level understanding. Okay. And then just to clarify, so there's the training set, which is X train and Y train, which we set earlier. And then there's also, if you see, there's something called validation data. And so basically that helps us measure how the model performs on like unseen data. So it's going to train on certain images from CFAR10. And then there's also images that it hasn't seen that's going to validate and see how well it does on that as well. And so we're all going to get our accuracies here. I think it's still going. So it says epoch 1 out of 3. Accuracy was 27%. Not super great. I think we can get better. Let's see how the next one does. So each time it runs the epoch, it kind of gets a little bit better, or that's at least the hope. And has anyone like ran theirs first one and gotten a certain amount? What was yours?
I got my first one. I got 27,
Okay, 27 also.
then 33, and
I
then
think mine.
35.
Oh, yours are already okay. I'll do it.
Yeah.
Okay, so yeah, 35% accuracy. So again, as I said, we're only running 3 epochs, which means we're not really going to get the full accuracy that we want. How to balance that? If you run too many of them, then it might result in the model only understanding what the training data was and never understanding anything new. So that's like a big thing that when like people working with AI and stuff have to see how many epochs and test out different things, and you can change the weights and parameters and other things accordingly. But yes, as I said, only 3 for now, and you can play around with that if you have time. Okay, almost done, but it looks like we got 33 on the second one, and it's probably going to make its way to 35 for third one. Did anyone else get similar results? Yeah? Anyone get different results? Okay. because we're all training on the same model and data set, it would all be very similar. Okay. Hi. Okay.
There we go with that.
Let's see. Okay, yes, we got to 35% basically. And you can see that over here if you didn't know. This accuracy, I'm just reading this decimal here and then converting that into like a percentage. So that's why I said 27% for this one. And like 35% here. Okay. Okay. So now step 5 is evaluating the model. And so now that the training is done, we're going to test it on the CFAR10 data set on the CFAR10 test set to see with the 10,000 images that it's never seen before. And so this is going to check the loss in accuracy, and ideally the accuracy should be high and the loss should be low. So I'm going to run this. So in deep learning, the training accuracy is often higher than the testing accuracy because the models can kind of overfit to the training data. So that's why this testing part is important. And let's see. Okay, so the test accuracy matched our training. It's, again, if you can see here, and it says here as well, because we printed out, but it's 35% accurate. So it's making its way, but not super ideal for now. Okay. The step 6 is now that we've trained it, we validated it, and we tested it, and we did the transfer learning. Now we're going to let our model test on a random image from the test set. And so we're going to pick an image and one sec, where are we right now? Okay, so we're gonna pick an image by using this index here. So you can change that to whatever you want. And we're gonna test that and see if it actually correctly predicts which class and which category that the image belongs to. So yes, and it's gonna do this based on those probabilities that we gave it. And so we're over here, by the way, just like predicting it, and then we're using this to display the image. Okay, so let's see. This model, so this is 35% accurate. So, you know, it's okay. But this model predicts that this is a bird. I have a feeling that this is not a bird. It looks kind of like a ship to me. Huh?
18.
Try 18? Okay, let's try 18. Why, did you try 18? Okay. Okay. So yeah, you can play around with these indexes. Predicted ship. Yay. This does look like a ship to me. So that's awesome. Okay. Did anyone else get any interesting results that you want to share? Yeah?
Next 0.
Index 0? Okay, let's try it. What did you, okay, I'll just do it here. Okay, so it predicts that's a truck. I'm honestly not sure what that is. But it has to be one of the 10 categories because that's the only pictures that we're showing. So it's either, oh, I think it could be a dog. Yeah, that's one of the categories. But yeah, okay, so as we can see, this is what it's doing with this 35% accuracy. Not too well, but like 18 it got correctly. Yes. Just to reiterate, we trained our model, we validated it, now we're testing it. And we apply the transfer learning on MobileNet with our data set CFAR 10. Okay, great. And now that we've done all of these parts, you have created your image classification, so good job. Now what we're gonna do is we're gonna upload our own image and take it a step further. So we're gonna see if it classifies our image correctly. So this is gonna be an image it's never seen before. And we are using that's why we imported earlier the Google Colabs file so that we can use it to upload an image and then process it so it matches the same format expected by MobileNet here. That's what we're doing all of this. And then yeah, so let's do that actually. Okay. What is one of the categories? Let's see.
Frog.
Frog is one of them. Okay. I'm gonna search up a picture of, is that okay if I do this in this computer? Okay. Image of a frog. Okay, cute. And then you guys go ahead and test it with one of these classes. Let me just pull those classes up really quick. I'm sure we have it here. Okay, yes. Classes are airplane, automobile, bird, cat, deer, dog, frog, horse, ship, or truck. Okay, I'm gonna give that to you as I do this as well, so you can think about what you want to do. What image should I use? I'm gonna choose this guy right here. Oh wait, I don't know how to do this on here. I'm going to save image as, okay. Frog, okay. So as just if you're kind of confused on how to do this, since we're doing this, we imported this like files.upload. We don't, when you click run, it's literally just gonna ask you down here to upload, like you can choose a file. So I'm gonna choose my file here. And then it should open your binder or whatever. Downloads frog. Okay, open this. Okay, it's uploading for classification, and it predicted it's a deer. So yeah, and by the way, the colors are like this because it was normalized, like when we divided by 255 and stuff like that. If you're wondering, but yeah, okay. So tell me what you guys did. Let's hear some other predictions. Did anyone get any that was accurate? Yeah.
And then different photo of a frog that was kind of like a side profile.
Oh yeah.
This, and I did get it.
Oh, we did get it correct. Okay. Okay. Good to know. Anyone else find interesting results?
Wonder.
What did that result?
Oh yeah, I got a bird and I put a picture of a cat in.
Okay, interesting.
For my dog, not a frog.
It
It is a very.
Yeah, at least we got the animal part, right? What happened?
Oh, nothing like from scratch and redoing it.
Oh, shoot. Okay. Well, yeah, catch up with us again.
Logan's normalized dog kind of looks like the dog, like the Blue's Clues. I
Oh my gosh, really? That's cute.
don't know why I made it blue, but
Oh my gosh, yeah.
she's a golden retriever.
Love that. Okay, well, yeah, I mean, so we just went through an entire like deep learning pipeline from loading the data set to using transfer learning to training the model, evaluating it, and then even testing it on new images. I hope you guys enjoyed that. I guess some of the key takeaways from that are that AI sees images as numbers and learns how to do it by how to process it by recognizing patterns. Transfer learning allows us to use a pre-trained model and then fine-tune it to our specific task instead of training it from scratch. And then lastly, our model, actually, let me go back to this because it's on here. Oh. Just kidding. Oh wait, that slide went away. Okay, it's okay, I'll just speak to it. Yes, our model classifies the images kind of okay, as we saw, and it has limitations because it only knows the categories it was trained on. So if you gave it something else, it literally just would not know and would try to categorize it. Along with that, we didn't do too many epochs on it. So if we had more training, that would probably be better. And then, yes, we can fine tune these models on different data sets other than CFAR 10 if you wanted to, accordingly, and different tasks. So yeah, if you want to take this a step further, you can try that out and or deploy the model on like a web app since we said it can be used for small edge devices and things. And yes, that was kind of the main part of today. So hope you enjoyed that and learned a little bit. These are some of the upcoming events that you should come to so you can continue learning about AI. If you want to speak to that later.
Sure.
Yeah.
Real quick, this Thursday, David is hosting our next research review, and I'll be on Transformers. That'll be in the CS lab at 11, so come hang out. And then after that, we got Rachel hosting board game socials. And so we'll have some snacks, we'll have some food, potentially more than snacks, so come and hang out. We got a lot of food these next few weeks, and then after that, since it's finals week, week 10, we're not gonna have a big presentation meeting, but we'll just have a room reserved. You're free to come hang out and use it as a study space because it's so hard to get study space during finals week on campus. We'll have some snacks. I'll probably do some work here and hang out. You're welcome to come. But yeah, so come this week on Thursday and next Sunday. And then we're done with the quarter. That's good.
Awesome. Yeah. Hope you guys enjoyed that. And are there any questions just before any discussion points or something?
I have
Yeah.
a question.
Yeah.
I have a valid question for
Yeah.
the group. Does anybody know why we never talked about what classes ImageNet had, right? We took this model and we said, okay, it was trained on ImageNet. And then we're gonna use that to like predict our 10 classes worth. We never talked about what ImageNet had. ImageNet could be all hot dogs and candy. We didn't predict hot dogs and candy. Why do we not care what ImageNet has in it? Yeah,
Didn't we get rid of the layer that it had in its classes?
did we?
Yes, we did. We basically got rid of this top layers. So it only has if it already had a college level understanding of images, we just took off all those layers that it actually learned. So now what it only knows is how to detect the textures and patterns and certain objects generally, but then we fine-tuned it on those 10 classes. So then it can only really understand those. Yeah. Do you have anything else?
Well said. Yeah.
Alright, round of applause. Lovely meeting. Also, for the board game social, I don't know if Leo mentioned it, but you're encouraged to bring your own board games as well. We will have some, but you're encouraged to bring your own. And then also, I just pinged everyone on the Discord for the project team applications. You came to our lovely computer vision workshop. If you want to do some more work with computer vision in a real life scenario, definitely check that out as well. Applications will be open for the next week on a rolling basis, so make sure you get them in before the deadline if you're interested. And since you're at the meeting, get a head start as well to get your application. Definitely check it out.
That'll be running through spring quarter, that's the goal.
Yeah, that'll be a running project until completion or end of the quarter.
Awesome.